Hello, everyone, and welcome back. So, you might be seeing some code on your screen, and it might seem very familiar to you. That's because this is the code that we wrote last time around. And today, what we want to do is we want to enhance this. We want to add more things in this process. Now, as part of our Crisp MLQ learning process, let's look at the Crisp MLQ mind map, right? And let's see what are the various steps that we can take. The steps that we can take here, specifically the ones that we are focused on last week. They were model building, and we looked at hyperparameter tuning, which falls under our evaluation process. Now, here we created our hyperparameter tuning. And then in the other file, we simply called these parameters and we started working on them. Now, what I want to do next is I want to look at the next step, which is my evaluation phase, right? How do I evaluate this model? And also, I want to focus on a very basic example on how to deal with errors. Okay. So let's look at all of those things. Okay. So here, the first thing that we want to do is we want to look at custom errors. Okay. So we want to define something that will take care of our errors for us. And these errors, they can be highly focused. So it doesn't have to be a general purpose error message. Okay. What it can contain is the various different things which you want to solve. Okay. Or the various different things which you want to focus on. Okay. So you can look at things like missing parameters. So here we have created a parameter grid, right? And we have provided 3 parameters, and we are calling that parameter grid here. And then we are using our grid search series, right? Now here, what if the parameter is missing? I've defined a parameter that I'm calling, but I've not given any values for it, right? So if I am getting that error, I need to be able to handle that. Okay. We can look at incompatible parameter grids, right? Now, random search has a different parameter grid in comparison to our grid search. Okay. Random search requires things which are not needed in our grid search. For example, one of the things which we require is the number of iterations. Now, what if I don't give the number of iterations? Here I have defined n iter equals to n iter. So we are trying to provide these iterations. Okay, so let's do one thing. Let's look at our code here and let's define a random search parameter. And in this, I will say random search tuning, which is the name of the class that I've defined here. Okay. And within this, I'll say I want the random forest classifier, and I'll pass this parameter grid, okay, that I have created. All right. Now this is straightforward. Then let's take a variable called best model. And in this, I'll say random search dot fit. And I need to give the training data, right? So X and Y train. And that's it. I'll not pass any value for my number of iterators. Okay. Now here, if you look at the random search, we have defined the number of iterators as 10 by default, but let's change that value. Let's keep no value as the default value. All right. We don't want to keep any value as my default value. And here, again, I'm not passing any parameter for the number of iterators. Okay. So what we will do then is we'll just write a quick print statement. And here I'll say, I'll give a f string. So best score for random search is, and then we can define our random search. We'll say get best parameters. Okay. So these are the changes that I will make to my table. Now, obviously, we have done some manipulation in the class itself, but this is just to drive home the point that I'm trying to make. Okay. So then what we will do is we will run this file. Okay. And now it has started the execution for this file. Obviously, the execution might take some time because we are also doing grid search. But after grid search, or as a matter of fact, let's comment out the grid search part. Okay. Let's not do any grid search here. Let's directly jump into random search so that we can get the output. Here, you can see that I'm getting a positional argument error. Okay. So this is a very common error that you can get. So we can figure out how to take care of this error. Okay. Now, if we create any kind of custom error class, what is the benefit of creating the custom error class? The benefit is that we will be able to solve errors easily. Okay. We will be able to deal with these errors easily. Okay. So by trying to deal with these errors, we can then look at what are the different options which are available to us. It will just make our debugging of the code that much easier. Okay. So then the next thing that I want to do here is I want to create some matrix. Now we have created this grid search model. We have gotten the best parameters and we are getting the best code, but on what basis, right? That is obviously a question that everyone who is interested in something like this will be asking that, okay, you're creating all of these parameters, you're creating all of these grids, but on what basis? How can you say that it is the best parameter? So we need to be able to define the results. Okay. So what we can do here is we can create some matrix. Now, obviously we can directly use the libraries, but what we are trying to do here is we are trying to extend the functionalities of our libraries. How can I increase? What are the different steps that my library can take? Okay. So that is the goal that we, okay. So we are going to still use libraries because there are two approaches that you can take here. One is the Pythonic approach. Now, the Pythonic approach relies on your Python programming abilities. And this is not to say that we don't have Python programming abilities or we are not capable of writing code in core Python. But core Python will require a lot of work that you might not be willing to do or that you might not need to do. Instead of willing, let's use the word need here because that makes more sense if we think about it. Logically, if a solution is available to you and you can enhance it, why would you not want to do that? Right? This is a very simple answer for a question that, okay, bro, I have these custom classes, custom errors, custom matrix. I want to create it completely from scratch using Python. You can do that. You can also do it in C++ or C, and then you can use Python to import it, right? So all of these options are available to you. Okay. So what we need to do here is we need to create our matrix, which we can then use to evaluate our process. Okay. So let's look into that. Let's see how we can customize a current code. Okay. Existing code, and we will just try to enhance it further. So I will bring this back. Okay. And after bringing this back, we will save this and let's rerun the file to see if we are able to get the answer if we don't provide any parameter value for that. Okay. So let it run. Now, obviously, right away, we can see that we are not getting any error. Okay. And of course, we are able to also get a solution. That's because we have defined a base value. Okay. So now, first thing that I want to do is I'll just close this Okay. Okay. So here I will import another metric, and this is called as make scorer. So make scorer will allow us to wrap custom scoring functions. So we talked about creating custom matrix, right? So this will try to return a scalar value based on the model's prediction. Okay. And this is the benefit of using sklearn or scikit-learn, whatever you want to call it. It will allow us to get making, it will allow us to get making score. Okay. Which is a function which will allow us to create custom scores. Okay. So how do we do all of this process? Okay. So first, let's create a class for my custom errors. Okay. And let's call this class hyper parameter error. And within this, we will take an exception. Okay. So we want to use the base exception class. Okay. So within this, we'll pass our doc string, and we will mention in the doc string that this is a custom exception for hyper parameter values. So the error measure that we are doing is specifically related to our hyper parameters. Okay. All right. And then we will create another class, which is called as matrix error. And here again, we will take our exception. Okay. And within the exception, we will mention custom exception for unsupported matrix. And again, we will say pass. So we have created our custom error and custom matrix class. Okay. Always make sure that you are following the proper procedures. Okay. So you should be able to write comments. You should write comments wherever they are necessary. Okay. So now, where to add the rest of these things? Okay. Where do I use my um, custom error and custom matrix? How do I integrate it within the code? Now, first thing that we need to look at is what is it that we are trying to solve? We are trying to optimize, or we are trying to extend the ability of our hyperparameter tuning. Okay. By doing this hyperparameter tuning extension, right, we can try to improve the flexibility that we have. Okay. So then let us look at how within our hyperparameter tuning class, we can go ahead and work on it. Okay. So within our class, what we'll do is we'll create another function, and I'll call this function called check scoring. So this method will take scoring as an input. Within this method, what do I want to do? First, I'll just quickly add a document here. We will say validate the scoring parameters. Okay. Add as many documents as you can. This will just help you in the future. Not just you, whoever is going to work with this code, it will help them a lot in the future. Okay. So now, what are the different accuracy measures that we are looking at? Now, since we are dealing with a classification based problem, how do I know it is a classification based problem? Because we have already tried to solve this problem using a random forest classifier. So what are the different measures that we can use for scoring in our classification problem? We have accuracy score, obviously the basic level of measures. We have precision, recall, and we also have the F1 score. Okay. So here we will state if is instance of scoring, and let's say the input is coming as a string. Okay. And we will say if scoring not in, let's pass a list of the measures that we want to look at. We want to look at accuracy. We want to look at precision. We want to look at recall, and we want to look at F1. Okay. So we are saying if it is not one of these measures, then what should you do? You should raise our metric error. Now, where is metric error? We defined our metric error right here. Okay. So here within the metric error, I will just quickly pass a string and I'll say unsupported metric. Okay. And then here we will just say scoring, right? And I'll say use a valid string or callable function. Okay. So this is how we can do that work for us. And then we can just return our scoring. Okay. Then now we talked about being able to wrap our custom scoring measure using the make scorer function. So here we will say elif callable scoring. So our scoring has to be callable in nature. And then we will say return make scorer. And within this, I will give the scoring balance. Okay. Finally, else we can define as raise, again, metric error. And then again, we can pass a string here. And in this string, we can say scoring must be either a valid string or a callable function. Okay. This is how it is going to work. Okay. Then this is for a meter. Now, what about our hyperparameter tuning parameters? What to do with that? What can I do there to make this feasible? What I'll do is I will go to those subclasses. Okay. Now within the subclasses, what have we done? After defining our class of grid search tuning and calling the main class of hyperparameter tuning, what are the next things that we want to do? Okay. So here we will say if not self dot param grid. Okay. Then what do we want it to do? We want it to raise a, okay. So sorry, we don't want to add it here. We want to add it within the fit method itself. So here I will say if not self dot param grid, because we will not be able to call all of these grids, etc., unless we are using our self, right? So that is a basic understanding of our procedure. Okay. So the next thing that we can do is we can raise our hyperparameter error. And within this, we'll say parameter grid cannot be empty. Okay. So we will create this error message. Now, we can do the same thing within this method. Okay. So after our doc string, always write all of these things after our doc string. So again, we will say cell.paramGrid, and we will again raise a hyperparameter error, and we can just mention parameters grid cannot be empty. Okay, so this is how it is going to work. Okay, now the next thing that I want to do is, what is my example of creating a custom grid here? So for example, let's say that I'll say from sklearn.matrix import F1 score, and here I can say def custom F1 matrix. And what are the inputs for this function? We will take y true and y print. Okay, and we will just simply return F1 score, and within F1 score again we will take the true value, and we will take the predicted value, and then I will say average I want you to take. So we have different options for average. So the average option that I'm taking here is macro. Okay, so I'm writing this not in my parameters file, but rather I'm just showing you it in the sample file. Okay, so now what are the updates that we have made here? The updates that we are making here are custom errors. So for custom errors, I have created a class called hyperparameter error. So it will raise an error when there is an issue with the parameter grid. And then we have also created a metric error. Okay. So this will be raised when the scoring matrix is not valid. So either it can be an unsupported string or a non-callable function. Okay. And this will allow us to get into the next customization that we have done. Okay. So we have created a custom matrix, and within the custom matrix, now this custom matrix we have created within our hyperparameter class itself. So it is a method. Okay. And the name of the method is check scoring. Now, using this method is added in the base class to handle validation of the scoring matrix. So if a string, let's say accuracy and precision is provided, it's checked against a list of supported matrix. Okay, so we will check, like, let's say that I want to do precision recall and F1 score. It will see if it is valid. But if I give something like RMSC or MSC, that will not work because that is not valid. Okay, so if a callable custom matrix, if a callable custom matrix function is provided, it is wrapped using make scorer from scikit-learn to make it compatible with the search algorithms. Okay, so this is what we need to do. Okay, then we also looked at how we can create custom matrix directly. Okay, so here we are just defining a custom F1 score value, and then it will just directly call that value. Okay, now what are the benefits that you get out of doing something like this? The benefits are that custom error will provide you with better error handling and debugging. Okay, now this is a very simple code because we are trying to show you how it works. But going forward in a real-time scenario, you will be expected to write much more complex codes. Okay, now the complexity of these codes is going to affect your ability to go through thousands and thousands of lines of code, right? So we want to have the ability to debug things very quickly. And that is what we will do here. Okay, this will allow for better error handling and debugging for incorrect hyperparameters and unsupported matrix. Okay, and the custom matrix will allow flexible use of any performance matrix, including custom ones like F1 score or any other user-defined matrix that you might be creating. So you don't necessarily have to create a matrix using scikit-learn, you can also use our custom matrix, which we have the ability to make. Okay. So you'll have to do it from scratch, obviously, and we recommend that you put that as a completely separate file, and just in your code, you call that file. Okay. So this is how it is going to work. Okay. Now, so this will just make your hyperparameter tuning process more robust and flexible, while it will also improve your code maintainability and usability. Okay. So then how to use it? We can use it here. After we define the parameter grid, right? I can say, let's just say number of iteration is 5. Okay. And then I will say scoring is my custom F1. Oops. We'll say custom F1 matrix. Okay. And then I will also just get the parameters and grid. So I will say print my best, this best parameter. So this will be best score. And this we have to optimize, and we have to say best parameters, right? So best parameters for random search is, and then here we will just simply say random search dot get best score, and that's it. Okay. Then I want to evaluate the model. So I will say ypred, and we will call this with the best model dot predict. Okay. When I want to predict my test values. Okay. And then we can also print the accuracy score. So we will say print test accuracy. And I'll try to get the accuracy score here. So we'll say accuracy score. We'll take our y test, which is my true value. And I will take the y pred, which is my predicted value. Okay, so this is how it works. So now let's quickly run this. We could also do the same thing for our grid search, but since grid search will take longer time, we don't want to spend time on that right now. We just want to see the output here. Okay, so let's run this and let's see the output that we get. Okay, so here we are getting a error message which says unexpected keyword. Okay, so let's see what is the mistake that has happened here. So there doesn't seem to be any mistake. Okay. Right. I don't need to define it here. Rather, I need to define it here. Okay. So now it is running. Okay. So it's saying that custom F1 score was taking 3 values, but only 2 are given. Okay. So it doesn't matter. Okay. We got the result that we wanted. Okay. So this is how our hyperparameter tuning can be optimized. Okay. So thank you so much for everyone who has joined in today. And with this, we complete our optimization of hyperparameter tunings. And then next week, we will continue from this point onwards. Okay, guys. Thank you, everyone. And we'll